operational management, we will have the concept of uh, availability, mean time to repair, mean time between failure. Yep, so this is a three term that normally go together. Again, availability, A, mean time to repair, MTTR. And we have mean time between failure. It means the mean time between just the next two failures. Okay, so if we have here the performance of a machine or of a factory or of a production line, okay, and here is the time. Okay, so if we work from 8 in the morning, okay, and at 16 in the afternoon, okay, 100% availability. It means that we will have the performance like this. Okay, we start at 8 and only 100% of our capacity, our performance, and then we end the working day at 16. Okay, but then we need a print. Yeah, we break, we do the print lunch break here from 12 to 13. Okay, for 1 hour. Okay, it's in we are failure. We have one failure. Okay, so we have availability. This is from A to here. This means that one. We have only 7 hour working in an over 8 hour of total time that we are at the company. So availability. So it will be around 7 divided by 8. So 80, 87.5% availability. Okay. And this is availability. Okay. But what about the mean time to repair? Okay. So this is the time, 1 hour. At the moment, it's fixed. Okay. But imagine, so if we have uh, not on one day, but do you observe this behavior in 1 month? Okay. In 1 month. Every day, sometime that you have a break at 12:01 and then make a break a little bit longer. So at 13:10, okay, or you make not exactly 1 hour, but only 15 minutes. Sometimes you take longer, 1 hour and 15 minutes. Okay, but again, in total per month, that you should have the mean value of 1 hour. Okay, so it's mean time to repair. Okay, it's not a fixed value. Sometimes it's higher, a bit higher. Sometimes it's a bit lower, but the mean value is 1 hour. Okay, and remember, simulation, do simulation, do math. No, they actually simulate the behavior happen in 1 day, and then they capture the same thing, the same behavior here. Yep, so it's not exactly 10 minutes will be taken for repair the system. Sometimes that they take 9, sometimes that they take 10 or 11. But in total, if you run the simulation several times, then you will have the mean value of 10 minutes. Okay. But now, if you have a look, so here to put, you can run the simulation and have the report time by time. But for short, what I can do is I can create here user interface with the display, and then I drag and drop the range into the display, and then there is a number here. So this is a throughput. So I can go back to event controller and deactivate the source summary report, because what I'm carrying now is just the number of product, and this is the number of product. Let me make it bigger. Okay, so this is a number. So when even, but now we know that. So this is the system where they have the random event. This means that it's not a fixed. Yep.
Can you open the setting station setting? Because
yep.
I do the same, but the number is not correct like you.
Yep, it's correct. When you have the different number, I'm explaining now why we have the different number. Because at the moment we don't have the fixed value, we don't have the fixed input for the system. Our system have the random event. What is the random? The random now is the mean time to repair. Okay, and our problem is not the deterministic problem, but we have the stochastic problem in the system. That's the reason why we run the simulation. We have different results from computer to computer. But in one computer, we will have the same result every time that you run the simulation. Okay, because this is how the working principle of the computer. They act with the random number variable. Okay, if you change the random variable now to something else, and then you rerun the system, you will have the different results. Okay, it's just like when you have the dice. You know the dice is the cube with 6 faces. In one faces that you have the points 1 2 3 4 5 2 1 2 3 4 5 6, and then when you roll the dice, you will have different result. It means that you have the same system, the dice, same behavior, rolling the dice, but every time that you do it, you have different results. So it means random. Okay, and then this is a stochastic problems. You need to run the simulation multiple times with different condition. Then you have different result. Then you make the statistics stable, and then you have the mean value, the maximum value, minimum value, the um, the chance that this will, what specific value will happen. So this is all about the statistic that we will study in chapter number 5, if I remember correctly. In chapter number 5, we will have, where is the chapter number 5, random event. Okay, and then we will deal with how you set the simulation, run a million times, collect the data for you, and show the report. Okay, so this is computational, the power of simulation, that you can run one simulation 100 times, 1,000 times, million times to collect the data and check what is the behavior of the random or the stochastic behavior of a system. Okay, we will know it in chapter 5. But at the moment, when you set up something, you have the different result from computer to another computer. But this is the correct behavior. Okay. Yep. Question from I don't know.
Can you click into the setting of the station again, Mr. Đức?
Yep. Yep.
10 minutes. And I also see like you set the setting like mean value time. Where is the setting in here?
Failures.
Yeah, failure. Yeah, failure.
Failures.
Yeah. Okay.
And then you need to renew, and then you can set up here the availability, mean time to repair, and so on.
Okay.
Okay.
Yeah, thank you.
And we can have the system here. And again, when you run the simulation, okay, they will give you the same value every time, unless you change the random number variant here. It's just like that. You change the environment condition. So if you have the dice, you roll the dice, they go with the same height, prop to the same surface of the table, with the same friction, contact with the same angle. Everything is the same. The result should be the same. But because we cannot guarantee that everything will be stay the same to maintain the same condition every time that we roll the dice, that reason why we have different results. Sometimes that we put the rolls higher, and then the contact point is become dense every time that you drop the dice, and that means that the condition changing time to time. That reason why you have the different results. Here, the commuter acting the same random number variant. It's just like that. You set a condition, environment condition for the system to run. Okay, so if I have the different friction, different uh, speed of wind, and so on, so it's roll the dice will have the different result. But as long as I have the same environment, or in the same random number variant, I will always have the same amount of here. Now we have even have a red here, so it's means that it's red. Okay.
Could you show again how to display the number of output?
The number of output is here, the 1, 2, 2.
Okay.
Of course, you can do it with the event controller, and then go to setting, show summary report. But every time that you play, there will be a report open, and then if you reset and play again, they keep generate the report, and it's too many reports, so I don't want to do that in that way. So I just care about the number. So I put the number here. How I do it? I go to user interface, select on display, okay, and simply drag and drop the range into the display. Okay, so then I have the throughput as a number just right next to the range. Okay. Question about exercise 3 week.